Hello and welcome back to Mr. Butler Maths. In this video I'm going to be covering finding the nth term. So the first sequence we're going to look at today is 2, 4, 6, 8, 10. Now you might recognise this as the 2 times table, but what I want you to notice is that each time we're going up by 2. The digits in white make up the sequence. At the top we have the position of each term. So 2 is the first term in our sequence, 4 is the second term, 6 is the third, and so on. So we're going up by 2 each time. Because we're going up by 2 each time, we write this as 2n. Now this is best demonstrated with an example. To find the third term, I would do 2 times 3, because n is the position and I want to find the third term. So to find the third term I have to do 2 times 3 and that gives me 6. And that will work for every term in this sequence. For the fifth term, 2 times 5 is 10. So I now know the nth term for the 2 times table. It is 2n. Let's have a look at a slightly different sequence. Now this sequence, 3, 5, 7, 9, 11, also goes up by 2 each time. So part of our nth term is going to be 2n. But there's more to it than just that, because it's not just the 2 times table. To get the first term of the bottom sequence, I just have to add 1 to the first term of the top sequence. 2 plus 1 gives me 3. To get the second term of the bottom sequence, I just have to add 1 to the second term of the top sequence. 4 plus 1 is 5. So this bottom sequence is actually just the 2 times table, but I've added 1 to each term. 2 times table plus 1. So as an nth term, that would be 2n from the 2 times table plus 1. Now let's look at a slightly different example. Let's take the sequence 4, 7, 10, 13, 16. Here we're going up by 3 each time. 4 plus 3 is 7, 7 plus 3 is 10, and so on. We're going up by 3 each time. Now in the previous example we used the 2 times table, but in this example, because we're going up by 3 each time, we want to use the 3 times table. So there's that, 3, 6, 9, 12, 15. With the 3 times table we're going up by 3 each time, and the nth term for the 3 times table is just going to be 3n. 3 times the position gives us the term. Now for the nth term of the bottom sequence, the first part is going to be 3n, because we're going up by 3 each time. But if we compare the 3 times table and our bottom sequence, we'll notice that again we're just adding 1 each time. 3 plus 1 gives me 4, 6 plus 1 gives me 7. So the nth term for the bottom sequence is going to be 3n plus 1, because I've added 1 to each term in the 3 times table. Let's look at a slightly different one. I'm going to leave the 3 times table there because that's still helpful, because this one is also going up by 3 each time. That means the first part of the nth term is also going to be 3n. The first part of the nth term always comes from how much you're going up by or down by each time. Now here, notice to get from the top sequence, the 3 times table, to the bottom sequence, we have to take away 1 from each term. So the nth term for the bottom sequence is 3n from the 3 times table, take away 1. So this sequence, 2, 5, 8, 11, 14, is just the 3 times table, taking away 1 from each term. I'm going to move on to a harder sequence now. This one, we're going down each time. So in the previous ones, we're going up by a constant amount. Here we're going down by a constant amount. We're going down by 3. Now, normally we'd use the 3 times table because we're changing by 3. But here we actually want to use the negative 3 times table, which is just the 3 times table but in the negative direction, because we're taking away 3 each time. The nth term for the negative 3 times table would be negative 3n. Because our bottom sequence follows a very similar pattern, the first part of its nth term is also going to be negative 3n. To get from the top sequence to the bottom sequence, we need to add 7. Negative 3 plus 7 gives me positive 4. Negative 6 plus 7 gives me positive 1, and so on. So the nth term for the bottom sequence is going to be negative 3n, because we're going down by 3 each time, plus 7. We've just shifted the negative 3 times table up by 7. So the nth term here is negative 3n plus 7. I'm now going to give you an example of where this doesn't work. Let's have a look at this sequence, 2, 4, 8, 16, 32. To get from the first term to the second term, we add 2. Then to get to the third, we add 4, then 8, then 16. This isn't the same each time. As a result, there's no times table that fits this sequence. The 2 times table goes up by 2 each time, so it can't be the 2 times table. In fact, I'm not going to go into how we find the nth term of this sequence. I'm just including this to show you that we can't use this method to find the nth term of every sequence. Some of you might have noticed that what is actually going on here is that we are multiplying by 2 each time, and that's because this is a geometric sequence. Okay, I'm going to leave that there for this video. If there are any other topics you'd like me to make a video on, just leave a comment. Thanks guys.